Hello there. Let's start our Network Plus series off with probably the most important thing to start a networking course with, and probably one of the most fundamental concepts for networking, which is the OSI model, or the Open Systems Interconnect model. Let's get into it. So the OSI model was developed by the ISO. Ironic how the letters are just rearranged. But the ISO, or the International Organization of Standards, developed this back in the 1970s. And its primary purpose is to standardize networking. Prior to the OSI model, every vendor was doing networking in their own proprietary fashion. And that's a problem for us, and would be a problem today as well. Because that meant if I went and bought my mainframe back then from a particular vendor, everything else I bought had to be from that vendor, otherwise they would not communicate. And that is obviously something we don't want. Thankfully, the Open Systems Interconnect model helped to create an open standard for networking. Now, there was an attempt to make it also a protocol suite as well, but that failed. For a working protocol suite, what we actually do use is TCP/IP, which will be in the next video. Thankfully though, TCP/IP does follow the OSI layers as far as functionality is concerned. So it is still helpful to be able to break our networking process down into the OSI model's working layers. So as I said, we still do use it. And it makes it a lot easier for us to conceptualize how networking works. Mainly because it's going to break the whole process down into 7 distinctive layers where different tasks are going to be performed. And what's quite nice is those layers are actually very sensible the more you think about them and the more you learn about them. What's also quite helpful as well is it helps to isolate the operations and also the faults that can occur in networking, which means it's very, very helpful when it comes to troubleshooting. Personally, I'm a big fan of what we call the bottom-up approach to troubleshooting when using the OSI model. I'll show you what I mean in a moment. First, let's go see what it looks like. So as I already said, there are 7 layers. I suggest you always write at layer 7 down to layer 1, and you'll see why with the names. So we have the application layer at the top. Below that we have the presentation layer, after which we have the session layer, then the transport layer. Then at layer 3 we have the network layer. Layer 2 is the data link layer, and layer 1 is the physical layer. And a bit of a spoiler, the physical layer is literally where the bits hit the wire, which is one of the reasons why I suggest working from top to bottom when memorizing this and writing it down. So these 7 layers are how we break up the entire networking process. Okay, and because we're breaking up the networking process and different tasks are performed at different layers, if something were to go wrong, let's say at layer 4, the transport layer, that will affect obviously anything that's working at layer 4 and above, but everything below will be fine. And this is why, like I said just now, I am a fan of using the bottom-up approach, because first of all, the physical layer helps me remember to check the basic stuff, plugged in, turned on, that kind of thing. And it's also very easy to verify. Then we can check layer 2 stuff, layer 3, and if everything seems fine, we keep moving on. And then when I get to layer 4, I start seeing a problem with whatever's going on in my network. And there I got a good suspicion that my problem originates there at layer 4. If I try to do it the other way around, where I work from the top down, I'd be at that application layer, testing stuff, nothing's working. Now, I don't know whether I must carry on testing at layer 7 or move down. So I'm going to have to make a decision. Do I move down or carry on? Then at layer 6, the same story is going to happen. Things are not working properly. I don't know if I must carry on testing at layer 6 or work my way down. Let's say I go down to layer 5 then. Do I carry on testing the session layer or do I move down to the transport layer because things are not working? And eventually when I get to the transport layer, still things are not working. Do I go down or not? Only when I go back down to layer 3 and things start working, I'm like, oh, okay. Probably at layer 4 is where the problem's at. So I personally like the idea of, okay, test this is working, test this is working, check this is working. Oh, something's not working, cool. Now I can start my troubleshooting. One of the best things I can advise you as well with the OSI model is when you do your Network Plus exam, you are going to get given a scrap piece of paper. I would highly suggest that you jot the OSI model down. That way, any question that asks you something where the OSI model will help you, you can look at that model on the paper instead of trying to imagine it and deal with the question in your brain. And believe you me, your brain's working capacity shrinks when you're sitting in an exam for some reason. So how are we going to be able to remember this? The names of the layers aren't so bad, but it's the order that matters, right? So I've got a little rhyme that I like to say to myself that works from layer 7 down to layer 1. And that rhyme is, all people seem to need data processed. I personally use that one, and I use it to this day, even though I've been working with networking for more years than I'd like to admit. Now, the reason why I like this one is it's a very easy rhyme, and it's very, very IT, very, very networking sounding related. So it's easy to remember. But there are other rhymes as well. One that I've seen pop up in quite a lot of courseware for Network Plus over the years works from layer 1 up to layer 7, but it does disturb me a little bit. And that rhyme is, please do not throw sausage pizza away. And the reason why this disturbs me is I really would like to know what kind of sausage is on this pizza that I'm not meant to throw away. Because some sausage, yeah, makes sense on pizza. Other sausages, however, nah, I don't know. Maybe I'm thinking too hard on this thing. But you know what? If you come across another rhyme that works for you, or you want to make your own, go for it. As long as you can remember all 7 layers in the correct order, I'm happy. But what are these layers doing? So let's break down their functionality here. Let's work our way from layer 7 down to layer 1. So at the application layer, this layer is going to give us the ability for applications to access networking services. Despite the name, this is not where your software programs exist or your applications exist. This is where your software applications engage with a network application service for networking. Think of writing an email. If you have Outlook from Microsoft on your computer, that application can actually work without any sort of networking at all. It'll be pretty useless as far as an email client is concerned, but you can draft your emails, look at your calendar, stuff like that, with zero network access. But when you press send on that email you've been drafting, Outlook engages with a network application service called SMTP, Simple Mail Transfer Protocol. Maybe SMTPS, I don't know how your network is set up. But it will then kick off the whole networking process. So the application layer is where we engage with network services. Cool, makes sense. And because of that, it's often referred to as the human-computer interaction layer. The presentation layer, though, is going to be a little bit more fun. So at the presentation layer, this is where we're going to make sure that data is formatted in a way that both the sender and the recipient can process and display the data as intended, regardless of anything. The sender could be using Windows, the recipient could be using Linux, and different font libraries and different applications are involved, but whatever email is being sent, the exact same text will appear, text effects will be correct, it'll all work smoothly. Now, another cool thing about the presentation layer, apart from making sure that everything is going to be correct on the recipient side as the sender intended, is that it also is where we can do some payload encryption, making sure that the data being transmitted is kept safe, while other data that might be necessary for the network appliances to process and successfully forward things can be in a readable format. So that's where you might find some higher layer encryption like TLS, for instance. Then we move on to the session layer. Now, the session layer is going to be quite useful for you, me, and everybody who likes to have fun online, because the session layer is going to set up, manage, and tear down a communication session to facilitate data transfer. Now, these sessions may exist as a client-to-client session, a client-to-server, or a server-to-server session, depending on how the upper layer application protocol is designed to communicate. Cool. By the way, client-to-server and server-to-client are going to be implied as just a bidirectional statement. But what's really useful to you, me, and everybody is that the session layer is able to keep simultaneous communications isolated and separated from one another. It is the reason why you could be watching this video in one tab on YouTube and be downloading a large file in another tab, and maybe have your Gmail or Facebook or something open in another browser tab. And at no point do any of those simultaneous network activities going on interfere with each other, because of the session layer's ability to keep those sessions isolated from one another. Fantastic. Also, a little bit of the presentation layer's encryption might trickle down into the session layer as well. Then comes the layer where the networking really gets involved and kicks off properly, which is the transport layer. This layer is going to prepare the data for transmission over the network. Now, as far as preparation is concerned, one of the first things it does is segmentation. Segmentation is where the transport layer is going to take whatever file it is you want to move and break it up into smaller, more manageable portions for the network. That email you want to send is probably actually bigger than what could fit in a single network packet. There's only so much space in the payload field, so we have to cut it up into more manageable portions. Think about when you're going to get a meal of some kind. No matter how hungry you are, you do not eat that plate of food in one mouthful. You're going to be taking it in several bites. Unless you go to one of those very fancy restaurants that charge you a lot of money for a very small amount of food on a very big plate. But I don't really consider that a meal. I consider that more of an appetizer. They cost way too much. So the segmentation layer is basically going to say to the network, here's small mouthfuls, little pieces you can handle. And it'll obviously label or sequence those segments so that the receiving device can reassemble them in the correct order, and also identify if any parts are missing and maybe request a retransmission of those missing parts. Then we move down to where I personally get very excited with networking, which is the network layer. And the reason why is this is where we handle logical addressing. It's where we look at how are we going to get traffic from the network that the sender is in to the network that the recipient is in. It's basically where we handle our routing. And it is also where we determine, if we need to do routing, how best to determine that best route to get to the destination network. Now, what I mean by how best to determine the best route is there are differing kinds of logic. Do I want to go for the fastest route? Do I want to go for the route that gives me the best response time? Do I want to avoid traffic and congestion? What dictates the best route? It's like when somebody's busy planning how to drive somewhere. Do you want to travel the shortest distance possible, or do you want to keep your travel time to a minimum, which means you might go a slightly out of the way route, but you could travel faster on that route and then maybe arrive a bit earlier. There's a lot of things to consider with the network layer and routing. Oh dear, I gave it away. This is where routers work. Oh well. Then down to the data link layer. This is where we handle physical addressing. I know it's a bit weird. We've got the physical layer, but you'll see why in a moment that physical addressing is handled at the data link layer. Now, the physical addressing is normally going to be used on the local network. So the focus will be next device delivery. I don't like the term next hop delivery, but that's a term that is used quite a lot in many courseware. But basically, the physical addressing helps my computer know, okay, where to send the traffic to next. The next device knows where to send it to next, and next, and next, each one step of the journey. Now, this will also include a bit of data formatting so that the packet, or the correct term I'll give you guys later, is able to meet the network media's standard for transmission. We're very big on standardization in networking, which guarantees that no matter who made the next device, who made the recipient's device, what software is running, it is able to process it. So the data link layer is also going to be very obsessed about making sure that we've got everything formatted correctly, especially for the network media in use. The media being the actual cables and the way we structure the data on those cables, or radio waves in the case of wireless. Then comes the physical layer. The physical layer's job is to take the binary bits and convert them into a signal. Now that signal may be an electrical voltage, a pulse of light, or a radio wave traveling through the air. By the way, radio waves cover everything from Bluetooth up to satellite transmissions and everything in between that involves no cable. And again, this is going to include a whole bunch of standards to ensure that the correct signal is generated and processed on both ends. both the sender and the receiving device. Now, because all the physical layer is worrying about doing is getting binary data into a signal, that is why the physical addressing is done at layer 2. Alrighty, so those are the main functions of those layers. But each of these layers needs to do some interesting processing. So we have this thing called encapsulation, which is how we take the data and package it basically to transmit it. You can imagine it sort of like wanting to send a parcel somewhere. You have to package that parcel so that it can be couriered or posted or whoever and whatever you use to get a parcel from point A to B. So let's take that data that we want to transmit. Now, for the most part, not much is going to happen at layer 7, layer 6, but we'll start seeing some stuff kick in at layer 5. With most networking services, like TCP/IP, which again I promise we're going to talk about in the next video, that's where most of the interesting stuff will be done. And to package this data, we're going to add something to it called a header. Now, this is an extra bit of information that will help the receiving device, possibly even intermediary devices between me and the recipient, be able to process and forward this data effectively. Think of it as a label on an envelope or a box that is about to be shipped. However, we're going to have multiple levels of labels now, because we're only at layer 5 right now, and I'm still sending data. So when we bring the data down to the transport layer, the thing is the header from the layer above is less relevant now because we're at layer 4, not layer 5. So a new header is applied for the transport layer services to work with, which is going to contain data for the transport layer to work with. And at the transport layer, the layer 5 header and the upper layer data just gets treated as what we call upper layer data. Cool. Then when we bring this down to layer 3 of the OSI model, same story applies. The layer 4 header has less relevance and meaning and use here. So at layer 3, we're going to add a new header that's going to contain all the information for logical addressing and routing and all that good stuff. And that layer 4 header just gets treated as upper layer data. Then, again, bringing it down to layer 2, the layer 3 header, not so useful, not so helpful. And we add a new header so that we can forward effectively at layer 2. And the layer 3 header and all the other headers and the actual data we want to transmit is just upper layer data. Now, a very interesting thing that happens at layer 2 is we also add a trailer. Now, the trailer usually at layer 2 is something called a frame check sequence. It's just a way for us to verify at layer 2 whether anything went wrong while the data was traveling from device 1 to device 2. And the way it works is actually quite ingenious. What the trailer does for the frame check sequence is it contains a number. It counts the number of binary ones from the beginning of the header all the way to the end of the data field, and it puts that number in the trailer. And the receiving device that gets this stuff at layer 2 can go and count those binary ones and then check the number in the trailer. And if that number doesn't match, it means that something went wrong during the transmission. Some binary bits must have flipped. It can't tell which bits flipped and how many, but it knows that this data is now corrupt and not worth forwarding, which leads to what we call a discarding operation, where the network appliance goes, well, this data is no longer any good to anybody, let's just throw it away and not waste my time or the next device's time processing garbage information. Then we go down to the physical layer, where the binary data gets converted into a signal. Fantastic. Now, one little thing I must admit here is when we went down from layer 5 to layer 4, I did not segment that data, mainly for keeping this diagram easy. But what probably would have happened is that light blue box that contains data would have probably been divided up into smaller portions, maybe let's say a dozen portions, and the same process would have been done to each of those 12 pieces, just with a different sequence number to keep track of. Is this part 1 of 12 or 3 of 12? But for simplicity's sake, the whole process would be the same regardless of whether I did the whole data or I segmented it properly. But this is quite cool because at every layer, we give it a header so that the devices that work at layer 2 or layer 3 or layer 4 or whatever can process and do what they need to do to forward this data to the ultimate recipient. and it all becomes part of the upper layer data as we go down. So just for visualization, you can actually imagine all of the headers forming part of the upper layer data. So it's nice to know that all that information is neatly packaged and ready to go for the appropriate network appliance to read it and process it. Now, this whole process was encapsulation, and it's normally what the sender goes through. As the recipient, I go through the reverse process called de-encapsulation, where I would read the stuff at layer 2, then decide to bring it up to layer 3, stripping away the layer 2 header, look at the layer 3 header, do my thing, strip it away, look at the layer 4 header, do my thing, strip it away, look at the layer 5 header, do what I need to do, strip it away, and then carry on processing the data appropriately. So it's absolutely well designed, this encapsulation and de-encapsulation process. It's wonderful. And visualized like this, it's going to help you a lot to understand how all the information is in the packet from the moment it leaves the sender. Now, the information can be modified by the network appliances in between the sender and the receiver. But we will learn about those events and circumstances as we work through these videos. Now, one last thing I want to talk to you guys about is something called a protocol data unit. It's the coolest way of saying, what's the name of the transmission unit at varying layers of the OSI model? Because we often use the term packet, but here's the thing. All network professionals, myself included, have fallen into a very bad habit of we just call it a packet no matter what. I might myself do it during some of these videos, but I'll probably at least say a layer 2 packet if I forget to call it what it really is. So the correct name, or protocol data unit term, for the transmission, while it's at layer 7, 6, and 5, is either the data or the message. Sometimes you could also call it the payload, that is okay, but most people stick with message. Then at the transport layer, the correct name for it is the segment, segmentation. Segment 1, segment 2, segment 3, segment 99, 100. You get the idea. Then at layer 3, the network layer, this is where we can call it a packet and be technically correct. But like I warned you, many network professionals, myself included, are going to call it a packet no matter what layer we're at. So you're going to have to get used to it. But try and change that if you can. Try and nudge the old fogies like me to be a bit better. Then the data link layer, a frame. That's the correct term for it at layer 2. And then at layer 1, most courses will tell you to call it a bit stream. I also like to remind you that regardless of whether it's a bit stream or not, it ultimately does become a signal that travels through a cable or a radio wave. But that is that for the introduction with the OSI model. I would like to thank you all for watching. And if you have any friends, family, or colleagues who may be interested in learning about networking and doing the Network Plus exam, feel free to share this with them. But otherwise, I'd like to say that is that, and I'll catch you in the next video.